Good evening, students. As per earlier information, one of the important concept, cooling of transformer. We know that as the rating of transformer increases, the magnetic loading and electric loading both are increases. As per kVA rating of transformer, both loadings are directly proportional to kVA rating. Hence, as the rating of transformer increases, uh, current loading increases. Magnetic loading is limited by its current density. Hence, another aspect for selection of current density depends upon current flowing through the conductor. Hence, as the kVA rating increases, directly proportional to current flowing through the conductor, which results increase of copper loss or I square R loss. As the I square R loss increases, definitely heating effect increases in windings. Hence, we have to see that temperature rise in the winding should be maintained some under safe limit. If it increases linearly, then there is a problem to insulation provided for the windings. Hence, uh, cooling system is necessary to control the temperature rise of the windings within under certain limits. Uh, this is shows that why the cooling is necessary. Then one simple diagram shows here. So it is the transformer tank. It is filled with the transformer oil, in which the whole transformer assembly is kept. Then side number of cooling tubes are provided. Hence, what is the amount of heat developed inside the windings? It should be transferred. Heat dissipation should be takes place by all three modes, that is conduction process, convection process and radiation process. Conduction means what is the amount of heat developed inside the winding. It transferred to core or some solid material. Hence, the heat is transferred by conduction process as shown in figure number 1. Then what is the amount of heat developed? Heat developed in the surface of windings and transferred to transformer oil. That is, heat is transferred from windings surface to transformer oil. That is convection. Number 2. Number 3. What is the amount of heat developed inside? Then that should be transformer oil to surface of walls of tank and then cooling tubes. This hotted oil goes top, hence circulates in cooling tubes. What is the amount of hot oil coming through the cooling tubes? It is surrounded by the atmospheric condition. Natural air absorbs the heat. In this manner, radiation process also takes place. So, as shown in figure 1, 2, 3, conduction, convection, radiation process. So, this is the how the heating process takes place in transformer. It is very introduction part. Types of cooling systems, directly you can go later on or we shall discuss later on. Now my intention to design a tank and cooling tubes. Before going to that, transformer oil, why you are using as a cooling medium? That is another important aspect. So we know that lambda convection for the transformer oil, that is the amount of specific heat dissipation due to the convection of oil is given by lambda convection equal to 40.3 theta by h to the power of 1 divided by 4 watts per meter square degree centigrade, where theta is the temperature difference of the surface relative to oil, then h is the height of dissipating surface in meters. So data this data consideration, the average working temperature of oil for 50 degree to 60 degree centigrade for theta equal to 20 degree centigrade and h equal to 0.5 to 1 meter, lambda convection is 80 to 100 watts per meter square degree centigrade. The same data, the same figure for the convection of air we are getting is 8. Then you can compare lambda convection of oil, lambda convection of air is 8. Hence, which is minimum 10 times more than air. Hence, we are transformer oil gives more cooling facilities or minimum 10 times more cooling facilities than air. Hence, transformer oil is used as one of the coolant. It is the one. Second point, temperature rise in plain walled tanks. So we are using the tank of the plain walled tanks or corrugated walled tanks. That is the another fashion. So now what is the how the heat transfer will takes place or heat dissipation takes place? There are two methods. One, it is takes place due to the radiation process. It is takes place due to the convection process. Number one, specific heat dissipation due to the radiation. It gives 6 watts per meter square degree centigrade due to the radiation action. Second, specific heat dissipation due to convection process, lambda convection. It is 6.5 watts per meter square degree centigrade. Hence, total heat specific heat dissipation due to plain walled tank, it is 12.5 watts per meter per degree centigrade. Hence, temperature rise equal to total loss divided by specific heat dissipation into heat dissipating surface of the tank. You consider Pi is the iron loss, Pc is the copper loss, St is the heat dissipating surface of tank. It is another important concept. These two concepts are foundations for my next derivation. Uh, it is one of the very important part of this design. So you will get one question again, as I told earlier in no load current. It is also another important concept of the derivation or problem. So, so the transformers provided with the cooling tubes increases the heat dissipating area. One concept tells. Then another point also it rises by using the number of cooling tubes which are provided side by the tank, which conceals some tank surface. It prevents the radiation of screened surface. So another concept tells that by using the tubes, improve the dissipation of loss by convection. So this is very important point. By using the cooling tubes, which improves the convection process of loss dissipation, the circulation of oil is due to more effective pressure heads produced by the columns of oils in the tubes. Another important factor, so how much increase in the loss dissipated, that is 35% increase in surface area, that we have to consider. Another important concept, 35% of the area of cooling tubes should be assumed it is increased. These 2 points you have to mention. After that, consider the dissipating surface of tank St, dissipating surface of the tubes x times St. Once again, St is the dissipating surface of tank, xst is dissipating surface of tube. Loss dissipated by the surface tank by radiation and convection. Previous only we have seen 6 plus 6.5 times of St. We are getting 12 point times of St. Hence, loss dissipated by the tubes by convection. So that is 6.5 times 6.5 usual process. How much increase in area? That is 35%. That's why 135 divided by 100 into xst. So this is effect due to convection of tubes 8.8 xst. Hence, total loss dissipated by the walls and tubes. Total loss dissipated by the tank walls and tubes. Then equation 1 plus equation 2. Actual total area of tank, walls and tubes. That is, we assume that St is the area of tank and actual area of tubes, that is x times St of the area of tubes. Then you are getting the equation 3. Then similarly we can go for loss dissipated per meter square of dissipating surface. That should be equal to total loss dissipated divided by total area. That is the another important relation. So you are getting the equation number 4. Very, very important. Temperature rise in the transformer with cooling tubes. That is theta. Theta should be given by total loss divided by loss dissipated. Hence, we have to construct the equation. We are knowing two types of losses are there. Iron loss is the Pi, copper loss is the Pc. Hence, total loss equal to Pi plus Pca. Hence, theta equal to total loss Pi plus Pc divided by St into 12.5 plus 8.8x. So we are getting the equation. You have to equate for x. Finally, you are getting x equal to 1 divided by 8.8. This is equation number 7. So this is the x value. After knowing the x value, it is possible to calculate total area of cooling tubes, x times of St. You are getting equation number 8. This equation number 8 provides total area of cooling tubes. Once you are knowing the total area of cooling tubes, we are in the edge of our final solution. Let us consider L is the length of tube, cooling tube in meter, D is the diameter of tube in meter, then surface area of each tube or one tube should be equal to 5dl. 5dl. Hence, lastly, total number of cooling tubes should be equal to total area of tubes divided by area of one tube. Hence, number of tubes equal to 1 divided by 8.8 5dl divided by Pi plus Pc divided by theta minus 12.5 St. Equation 9 gives total number of tubes estimation or calculation. This formula is very, very important to solve the problems. Please practice and remember equation number 9. Earlier two things are you assume there. You should be required earlier two explanations of the concepts where you can start the design of tank and tubes. From that you practice to get the